Hi everyone. Very good morning, all of you. After a long time, we are meeting in the YouTube and special classes. Right. Very good morning, everyone. How are you all? Everyone, how are you? Audio and video both are clear? Yeah, Shruti, good morning. Right. So these are quick revision courses. So mostly 15-20 days, 15-20 hours, this steel structures will get over. Right. We will not be discussing as depth as that of which one? This plus courses. These are in a revision type, right? These are discussed in which one? This is a revision manner, right? Is not? So those who are in a hurry and you wanted to quickly complete all the subjects now, for all of you this is useful, you can say, right? So this is which one? This is steel structures, right? Brahmastra batch 2.0 for gate 2024 mainly, right? Umang, good morning. Right, all of you had your tea, coffee, hot water, juice, breakfast, everything? Nothing. Tea, coffee, hot water, juice, breakfast over. So these are the plus courses starting. Brahmastra plus batches for this gate 2024, right? Plus batches also starting. Little more detailed discussions will be there in that. Okay. So Amit sir started RCC on 13th, right? So these are mission batch, right? Mission batch for which one? This is 2025, right? You can see. Uh, yes, whole steel structures I'll discuss here in a quick manner, right? In a quick manner, we'll be finishing it off, okay, Manish? In a quick manner, we'll be finishing it off, right? So, like when you are doing the revision for second time, what you are doing, how will you do that? Like that, we'll be finishing it off in a quick manner, and mostly 20-25 hours, maximum 20 hours only we'll try to keep, or if not possible 25 hours we'll try to keep it, okay? 25 days we'll finish off this steel. Three subjects I'll be doing here. So one is your surveying, transportation and steel structures, right? These three subjects I'll be doing in the free classes for full, okay? Right. uh, so here examine. Right. So these are GATE and ESC civil dream you can fulfill, right? So what are the features of this plus subscription you are having? You can raise your hand and ask your doubt, and you can get the class handouts. In class you can have polls, right? Daily practice problems and educator community, and yeah, you can just follow my community. You will be getting all the details. Are you following my profile? Examine. Study material you will be getting, unlimited access to all the courses. Top educators will be teaching, right? So those who are unable to pay the entire amount for plus subscription at a time, you can just go for this EMI option, right? No cost EMI option is given by Unacademy, you can say, right? That too is 0% interest, right? Daily scholarship tests are also going on. Depending upon your rank, you will be having which one, you will be getting this amount of discount, okay? So now coming to this, it will be starting on which one? You will be starting on which one? 16th October you will be starting, okay? Today it will be started. Every day the class will be at which one? This 8:30 a.m. to this 9:30 a.m., right? So 8:30 a.m. to this 9:30 a.m. every day the classes will be happening, right? So don't miss this 1 hour class only, right? 1 hour class every day I'll take. What I'll do is today I am taking in which one? This YouTube now. Tomorrow and after tomorrow I'll be continuing these classes in which one? This Unacademy app, okay? So first class will be having on YouTube, second and third classes will be having in Unacademy app, right? Fourth class will be having in YouTube, fifth and sixth class will be having in Unacademy app, right? Like that will be having. So this is a syllabus for GATE steel structures. This is a syllabus for ESC steel structures, and these are all the topics we will be discussing, okay? All these topics we'll be discussing, right? Whatever the topics you have mentioned now, basics of steel design, design of connections, concentric and eccentric, riveted, bolted and welded, eccentric connections, type 1 and type 2 connections, okay? Tension members, right? Compression members, right? Built up columns, column bases, column splices, beams, plate girder design, gantry girder, right? Roof truss. All these topics I'll be discussing here, right? But in a quick manner we'll be completing, right? Okay? Right. So coming to this, before we go for this, right, what is that weightage? What is the weightage of this steel structures, you can say? Weightage, if you just observe, na? Right, minimum least number of possible marks in gate till now from steel structure are 2. Highest number of marks till now are which one? This is 5. So 2 to 5 marks you will be getting, right? 2 to 5 marks you will be getting from which one? This is steel structures. In which one? In gate examination. Okay. And now ESC, what is that? 9 to 13 questions you will be getting, right? Yes. 9 to 13 questions you will be getting in which one? This ESC. Okay. 9 to 13 questions you will be getting which one? This ESC. You can write 9 to 13 questions you will be getting ESC. Here I cannot give the link now. Tomorrow you come to, all of you come to this special class. There I will be providing the link. Okay. Right. So these are the distributions we are having, right? Materials, riveted and bolted joints, right? Welded connections, eccentric joints, right? These are the weightages if you just observe, right, from each and every topic in the last 30 years of your GATE examination, right? Now coming to this, shall we start the first chapter? So you can make notes of it, right? So that what will happen, for quick revision point of view, these are useful, okay? Whenever you are revising just before the examination, these notes will be useful, and it's like a short notes, okay? It's like it will be useful like which one? This quick revision notes or this is short notes, right? Just make this chapter reading, all of you, or shall I give the PDF directly? You will write, or I'll give the class PDF directly. How you want? Right. Okay. Introduction to this is steel structures and design, you can say. Right. We'll be starting. Okay. Why steel structural design course? You know, to get marks only. Right. Here. Now, coming to this, if you just observe, what is that steel first of all? What is that steel, everyone? What is that steel, all of you? Steel is a pure metal or it is an alloy? Steel is a pure metal or it is an alloy? It is an alloy, na? What is the meaning of this alloy, you can say? What is the meaning of this alloy? Only one material will be there, or it is the composite material? Yes, absolutely composite material, right? What is that, you can say? The main component is which one? This iron. Is not Fe is nothing but your which one? This iron. Main component is iron and carbon. Depending upon the strength improvement or strength required, you have to go for this carbon and other metals, right? Other elements also will be adding, right? So this is generally your which one? This is steel, you can say, right? Is not? This is your steel, right? And now there are different types of this steel you are having, right? What are the different types of this steel? First one is what? Reinforcing steel. So what is the meaning of this reinforcing steel? Second one is what? Structural steel. ये क्या है? reinforcing steel क्या है? उसका मतलब क्या है? reinforcing steel का मतलब, so ये main component of steel है क्या, और it is just to improve certain properties of other material? It is mainly as a secondary material, right? It is a primary material or it is a secondary material? It's just a secondary material, right? It's just a secondary material, right? And it is for which purpose? It is to improve what? Improve properties of other material, right? Yes. It is to improve properties of which one? These other materials, na? Like that. Like which one? Reinforcement, right? Like reinforcement in which one? This RCC and this PSC, na? Pre-stressed concrete. RCC and this PSC, na? In case of this RCC and this PSC, that steel will be as a main material or steel is a secondary material? Steel is a secondary material, na? Yes or no? Like that. Structural steel means So there in the RCC, concrete is the main material. Now tell me that yellow color is okay or white color is okay or both are okay? Everyone. Both colors are looking good only? Visible on the black background? Both the colors okay, or I'll continue with only white? Right. Structural steel. What is the structural steel? Steel as which one? Steel as the main element. Na? Okay, I'll go with both. Steel as the main element, you can say, if you just have said steel as the main element, right? So steel as the main element means compression, tension, shear, all will be taken by this steel only or not? Compression, tension, all will be taken by this steel only or not? Yes, absolutely right. So are you making notes? Just make a notes and tell me. Note it and tell me, all of you. I'll wait. Mostly today and tomorrow this first chapter gets over. We'll be doing the questions also, all of you. We'll be doing the questions also, okay? And first of all, what is the meaning of this analysis and design? State exam weightage, it is depending upon your state, and it is different for different states, you can say, right? State exams also it is having higher weightage. So those who are preparing for the state exams also, this course will be very much useful, you can say, okay? So what is the meaning of this analysis, you can say? Analysis is which one? This is determining, right? Determining what? Design forces. So design forces क्या क्या रहता है हमारा structures में? What will be the design forces? Like which one? Shear force, bending moment, next axial force, twisting moment, etc. Na? These are all your design forces only or not? Yes or no? These are all your design forces only. Design क्या है? Analysis means whenever you are calculating this shear force and also deflections, determining design forces and deformations. Which deformations? Deflection, rotation, all these are deformations only, no? Deflections and rotations are also the deformations only, or not everyone? Deflections and these rotations also the deformations only, you can say, right? Now, what is the meaning of this design? Tell me. Anyone? What is the meaning of this design? Analysis, you know, calculation of this design forces, right? What is the meaning of this design then? So whenever you are applying a bending moment on this structure has to resist this bending moment. Na? Which property will resist this bending moment? Material property will resist this bending moment, and geometry property also will resist, right? So what is the meaning of this design, everyone? What is the meaning of this design, all of you? Deciding. Deciding or calculating, what you can say? Deciding or calculating which one? Deciding or this calculating the material and geometry properties. Material properties we have to decide, and geometry properties also we have to decide, right? What is the width, what is the depth, what is the shape, right? Material properties for which purpose? What is the main purpose? To resist the design forces only, no? It is to resist the design forces only or not? It is to resist the design forces only, if you just observe, right? Got it now? The difference between the analysis and the design, you understood, everyone? The difference between the analysis and this design, you understood, everyone? So means material grade. So what is the meaning of this material grade? We have to decide. If it is an RCC, M20, M30, like that. If it is a steel, which type of this steel we are deciding, right? FE 410 grade, right? FE 510, FE 500 grade, right? Like that. FE 800, like that. Material grade plus what else we'll be discussing? Shape of cross section also will decide now. Shape of cross section, and what is that you can say? Shape of cross section plus which one? This geometry. What is the meaning of this geometry? dimensions, right? Geometry, that is nothing but your dimensions, right? These are all, if you are deciding now, that is called as your which one, design. Is it clear? Everyone, the difference between the analysis and this design understood, all of you? Difference between the analysis and design understood, everyone? Right, this is a basic difference between this analysis and design, right? Noted? Noted, tell me. Once noted, tell me, I'll try to move on to the next one. Done? Right. So now we'll be going on to this one. Generally, if at all you are representing the steel nomenclature, how will you represent? This nomenclature is very, very important, right? Nomenclature means what? A representation. Suppose if it is a reinforcing steel, na? Whenever it is a reinforcing steel, for example, Fe250, right? What is the meaning of this Fe250? Tell me. What is that 250 is telling? Here that 250 is telling which one? This is a yield stress, right? What is that 250 is telling? It is representing the yield or this elastic strength. Yield or this elastic strength, right? And whenever it is a structural steel, so we are interested in this structural steel or we are interested in this elastic steel, reinforcing steel? We should be studying about this structural steel or reinforcing steel, everyone. We should be studying about this structural steel whenever it is mentioned as this Fe410, right? What is it considered? Whenever we are mentioning it as this Fe410, right? Fe410E250 like that, na? It is mentioned, right? E250 or E240, it is mentioned like this. What you can understand from that? This this 410 will be representing what? Yield strength or this ultimate strength. If 410 will be representing which one? This is ultimate strength Fu, na? Ultimate tensile strength, right? UTS, right? And what is this 250 is representing? That is representing that Fi. Got it now? The nomenclature or the representation of this structural steel and this reinforcing steel, everyone? Is it clear? All of you? Clear, all of you? Everyone? No. Why we have to go for this steel structure first of all? The first and foremost advantage of this steel structures over which one? Other. What is the meaning of this other? You can say reinforced concrete structures and these wooden structures and all these structures, na? Is that no? Right. Now if you consider, right, what is that you can say? What is that you can say? If you just observe, what are the main advantages? You can say, anyone tell me? What is the first and foremost advantage of this? Compared to your concrete, these steel structures will show this a high strength or less strength, everyone? Compared to this concrete, these steel structures will show high strength or less strength, you can say? Very high strength they will show, no? If you consider these are the dimensions. For the same dimensions, who will show more strength? Steel structure will show more strength or concrete structure will show more strength, right? E250, right? E250 will be given, right? Fe410, E250 will be given, right? So in bracket E250, that is the nomenclature representation actually. Or directly what they will do is, they will just simply represent that Fe410 only. Directly they may represent this Fe410 also, right? So then you have to take it as which one? This Fu, that Fu will be which one? This ultimate tensile strength, okay? Ultimate tensile strength, right? This is the actual nomenclature, okay? If you observe the codal provisions now, then you can understand, right? This is the actual nomenclature you are having, right? Yes, now, got it? Now, first and foremost advantage is what? Very high strength. What is the meaning of this very high strength, you can say? Even for smaller dimension, you will be getting this larger strength, na? Yes, no? Second advantage is what? more strength by weight ratio. So what is that strength by this weight ratio? If you just observe, strength by weight is nothing but your economy checking only now, output by this input checking only or not? It is that output by this input checking only. What is that output? You can say, if you just observe, what is that output? You can say strength na. We have to get more strength from that, obviously, right? More strength, right? Output is your strength, input is which one? Your weight, right? More weight is used means more dimensions or less dimensions. More weight is used means more dimensions, you can say, right? Is it clear? Is that? So this is second advantage, right? And what is the third advantage, you can say? So what is the next advantage of this is steel structure, everyone? Okay, I'll try to write here itself. So what are the other advantages, right? The next third advantage is what? So more ductility will be there na. What is the advantage of this more ductility? In case of your earthquake, right? In case of your earthquake na, earthquake, right? In case of your earthquake resistance na, this ductility is very much important criteria. More ductility you are having means that more earthquake resistance will be available, right? Because if the structures are they will be subjected to vibration like this during that. So if they are suddenly failed without much deformations, if they are failing suddenly, brittle material, what will happen? It is advantageous or it is not advantageous? It is not required in case of earthquake, right? But during this vibration, it should not fail or break suddenly. It should show more amount of ductility. It should deform only. So that what will happen? Whenever the earthquake starts, na, the people can vacate from this structure easily. They will be finding some time, right? Which one is better? Tell me now. Which one is better? Tell me now. Ductile material is better, or in case of these earthquakes, or brittle material is better? In case of these earthquakes, ductile material is better or brittle material is better? Which one is better? Obviously, ductile material is better, right? Is it clear? Now, what is another advantage? Generally, if you are going for this concrete construction, it will take a lot of time, na? 6 months time almost it will take. But if this one, na, yeah, steel is very much ductile, you have to take it, right? But it is ductile now. Whenever it is a ductile material, right, what will happen? Sorry, steel it will take more time or less time? Steel it will take which one? This less time of construction, right? Fast construction. Just within 1 week, within 1 month also we can complete the construction, right? Fast construction, right? So is it clear, everyone? These 4 points for advantages. Are this clear, everyone? Right? No. So next advantage, right? What is the next advantage? You can say long life. You can say, if you just observe, what is the meaning of this long life? Longer life. So what is the meaning of this longer life, right? These steel structures will stay for more time, more amount of time or less amount of time. Your children, your grandchildren also can stay in that, right? So what is the second point? More strength by weight ratio, right? More strength by weight ratio, right? Strength by weight ratio is nothing but, so for lesser weight of this structure itself will be getting more strength. I told you na, lesser weight means lesser dimensions. For lesser dimensions of the structure, lesser weight. For lesser weight itself, the load resisting capacity will be higher, right? Like that. Got it now, Shruti? Any other doubts anywhere here in these points? Anyone else? Anyone having any other doubts? Clear now? Clear now or not? Hello? Right. Okay. Shall I move? Now, sixth point. What is the sixth advantage? You can say, if you just observe, elasticity, right? More elasticity available, na? And more uniformity is also available or not? More elasticity and this more uniformity is also available, na? Listen, more elasticity and this more uniformity is available, right? What is the meaning of this elasticity? You can say, what is the meaning of elasticity? It is a property of material by which it can regain the original shape and size after the removal of these loads. Na? Uniformity of material, right? It is a homogeneous behavior it will show or non-homogeneous behavior it will show. It will show the homogeneous behavior it will show. Na? And now what is another advantage you can say? Easy to repair, right? Easy repair and modifications, right? Easy repair and modifications you can say, right? Suppose in case of which one stuck in case of your concrete, there is a beam got damaged. Now if you wanted to replace that beam, is it possible easily? No. But if it is a steel structure, what we need to do? You provide a temporary support to the slab. So bolts, nickel, carrot, we remove the bolts and you remove that entire I section of this beam and you place a new I section of this beam there and again you place the bolts, right? So it is easy to repair or not? It is very easy to repair, na? Yes or no? It is very easy to repair, right? Now what is it you can say? Highest scrap value. What is the meaning of this highest scrap value? Yes, scrap value क्या है? What is the meaning of this highest scrap value, all of you? External retrofitting. Yes, external retrofitting will be easy. And removing the entire beam and adding a new beam is also possible, na? Yes or no? Removing the entire beam, existing beam, and adding the new beam or column, whatever the member you want, you can replace. If it is a bolted connection, riveted and welded, it may be little difficult, but that also you can do it. But if it is a bolted, na, easily you can replace. Is na? Got it now? What is the scrap value? Once you are using this structure for 20-30 years, then you are demolishing. Even if you sell that as steel, now you will be getting a considerable amount of this money, right? Yeah, dismantling. After dismantling the structure, you will be getting some money from that steel. It's not that is your scrap value. But if it is a concrete, if it is a concrete, will you be able to get any money after dismantling or after demolishing? No. No, right? So these concrete materials, once your structure is demolished, right, it will be useless, right? No use for that, right? No use of this, right? Got it? Now, next one. This is very important, right? Highest quality. What is that highest quality? See, whenever you are saying that na, M20 concrete means that has to show 28 days strength as which one? This 28 days strength as which one? This 20 MPa. But will it, do you give guarantee? No. So that's why we are applying which one? This very much 1.5 factor of safety, and FCK we are not taking, and 0.67 FCK we are using in the design. But still, if you are saying it as FE 250, FY equal to 250 MPa means almost it will show 250 MPa only. So you need not reduce this, you need not reduce which one is you need not reduce this FI. There in the concrete you are reducing the FCK to 0.6 FCK, and on that design factor of safety we are applying partial safety factor. But here directly on this FI only we are applying. So because good quality is maintained, so whatever the expected strength will be equal to what is the available strength, right? Like that. So these are all the various advantages we are having now, right? These are all the various advantages of this steel structure, right? So do you give guarantee that only advantages will be there for any structure, or there will be disadvantages also possible? Only advantages are only there, or disadvantages also possible, you can say, right? Disadvantages also possible, na? So what are the disadvantages you can say? High temperature susceptible, na? What is that high temperature susceptible you can say? What is that high temperature susceptible? Right. Whenever, suppose if somebody is cooking something in this which one the top floor, and their stove is in contact with which one, this is steel wall. So what happens, the bottom floor, so bottom so after 10 floors bottom, so what happens, one fellow is sleeping by keeping his head on this wall. What happens, the temperature effect may be passing up, It is easily temperature conducting or not? High temperature susceptible, right? And what is another disadvantage you can say? Yes, corrosion is the main biggest enemy of the steel structure or not? Corrosion is the biggest enemy of which one? This is steel structure, right? So we need to do which one? Regular painting and this maintenance is required or not? Is that no? Right? And so temperature susceptible, so fireproof treatment we have to do for this, right? To avoid this temperature effects, fireproof treatment we have to do. To avoid this corrosion, regular painting and this maintenance activities are required, right? Is it clear? So yeah, expansion of the steel happens, right? So yet places of which one? This is stress concentration. What is the meaning of this stress concentration? Sudden change in the stress, Yet places of this stress concentration, right? At places of this stress concentration, At places of this stress concentration, if you just observe, what is the possibility you are having? It loses its ductility. What is it disadvantage? It loses its what? It loses its ductility. Whenever it is losing its ductility, it is good or it is bad, you can say. It is bad, like that. So is it clear, everyone? The advantages and these disadvantages of this steel as a structural members. Is it clear, everyone? Right, just note it and tell me. Noted, everyone? Are you noting? Note this and tell me. Yeah, stress concentration means a sudden change in the stress, you can say, right? Wherever there is a sudden change in the stress, suppose एक axial wala. Okay, you're also asking about the third one. Okay, Shruti, I'm explaining here, don't worry. Suppose a small example I'm taking. एक axially loaded वाला member है हमारे पास, हमारे स्टील स्ट्रक्चर में एक एक्सियली लोडेड मेंबर है, राइट? क्या होगा? इसको फोर्स अप्लाई कर रहे हैं ना हमने, 1000 न्यूटन्स वी आर अप्लाइंग. दिस इज आल्सो व्हिच वन? दिस इज सेम 1000 न्यूटन्स ओनली, but this is the cross section area. What is that? You can have this cross section area. This is your 1000 millimeter square. So let us say it is which one? This is 500 millimeter square. Not overload, not overload. I am explaining, na, don't worry. So here this is your point A. So yet this point A, what happened? Just left, what is the stress? Just left, what is the stress, you can say? This is your 1000 Newton by which one? This is 1000 millimeter square, right? What is it? It comes to be, this is your 1 MPa, na? And at this A only, what is that, you can say? Just right side, if you just observe, what is that, you can say? That is a stress will be equal to that load 1000 divided by area of cross section will be 500, so that is your 2 MPa. So this is sudden change in the stress at a single point is called as your stress concentration, right? Now got it, everyone? What is the meaning of the stress concentration? Yet this place, what happens? Yet this junction where the cross sections are changing suddenly, so what happens? Stress concentration. Stress concentration, right? Isna? Got it? Yeah. Good morning, Selim. So got it now, everyone? Shruti, Chetan, understood the meaning of stress concentration? इसका मतलब क्या है? Yeah, Selim, yes, right. All will be discussed, but in a quick manner we'll be discussing, right? Okay, so it will be useful, right? You are attending for the first time also, it is suitable, no problem. Or you completed also, it is suitable, right? For everyone it is suitable. And everyone, right? Got it? Right? Clear enough? Now if you just observe, what is that code we have to use for this design? What is the code we have to use for this standards and these specifications? Yeah, in plus it is not yet started. Not yet started means already one time done for 2024 people. For 2024 already one time done. So next time we'll be doing, don't worry. We'll start, don't worry. We'll do it. But compared to this, that is full length course, right? That is full length course. Full length course is different, huh? Full length course means detailed discussion होगा उसमें, right? Full length course is different, this is different, okay? Full length course is different, this is different, right? This is which one? This, it's like a revision course, okay? It's like a quick revision course, right? Yeah. Umang, you want me to wait at the previous one or here only? Previous slide you want me to wait? Fourth slide? So what is the code for this standards and this specifications? IS 800 2007, Indian Standard 800, which one? 2007 code, right? Okay, I'll wait. Note it and tell me this fourth slide. Same slide only? Okay. This slide only? Yeah, I mean this slide only, no? I'm not moving. So this is based on which one? This is a new code, na? This is your which one? This is a new code, you can say, right? New code or latest code. But old code, IS 800, what is it? 1987, right? What is that IS 800 1987 if you just observe? This was the old code, right? This was the old code, right? Here old code was completely based on which one? This working stress method only, na? This is a new code if you just observe. It is working stress method as well as which one? This is limit state method, right? Both are added here, na? Both are added, right? Like that. Got it? So this is second one. And what is another one required? IS handbook number 1, right? Indian standard, what is it you can say? Indian standard handbook number 1. So what it is telling if you just observe? Properties of steel sections. That is nothing but your steel tables, na? IS handbook 1, right? What is the meaning of this IS handbook 1? You can say it is nothing but your steel tables, right? Steel tables use किया है क्या नहीं अपने आपका बीटेक में, बीटेक स्टील स्ट्रक्चर्स डिजाइन में स्टील टेबल्स यूज किया है क्या नहीं? You have used steel tables or not? Not tell me. Yeah, steel table all. Noted? Once noted, tell me all of you. Right. Noted? Done, Umang? So we should study about which one this types of this structural steel, because structural steel is only important in case of the steel design, or reinforcing steel is important. Structural steel is only mainly important in our steel designs, now isn't it? So what are these types of this structural steel if you just observe? The first and foremost one is what? Standard quality steel. What is it you can say all of you? Standard quality steel, right? SQS, right? It is according to which one if you just observe? It is as per this Indian standard 226, na? It is as per this Indian standard 226, right? So okay, I'll write the points regarding this, and then we'll go on to the other thing. So standard quality steel, right? Indian standard 226 is the code you have to follow for getting the properties of this, right? These code numbers also will be important, right? So what is that standard quality steel? It is the most commonly used one. Okay, it is a most common structural steel, right? SSC is nothing but your not stainless steel. Don't think that SSC is stainless steel. What is the SS? You can say structural steel. Okay, what is the SS? Structural steel. So most common structural steel, right? Most commonly used is this structural steel, right? Now what is the carbon content? You can say steel means it is having the carbon, definitely now. What is the carbon content in this? What is the carbon content? You can say carbon content is generally varying from which one? This 0.23 to this 0.25, 0.23 to 0.25 percentage. And what is that? You can say percentage elongation when you are conducting this tension test. After the tension test is over, at what is the percentage elongation will be getting for this? 23 percentage, you can say, right? 23 percentage you can say, right? And what you can do, bolting and riveting it can be done. The connection properties, if you just observe, bolting plus this riveting, what you can do? Bolting plus this riveting you can do for which one? Any thickness. Bolting and riveting can be done for any thickness, but welding type of connection can be done for which one? So this 20 mm, lesser than 20 mm thick members only. Because if it is beyond that, the welding will not fit properly, right? That welding will fit properly or welding will not fit properly, right? Welding will not fit properly. And what is the designation? If you just observe, what is the designation of this nomenclature of this standard quality steel? What is the designation of this one? How will it be represented? The designation means that a notation, right? It is FE410, right? FE410, yes, right? FE410, yes, right? What is the meaning of this 410 here? FE410, yes, means that 410 is what? FE410, yes, right? That yes represents the standard quality steel, right? Yes represents which one? This is standard quality steel. And what is that 410 represents? That 410 represents this ultimate strength FU, na? Is or no? And sometimes they will be mentioning that E250 also in the brackets, right? If they are mentioning, okay. If they are not mentioning, no problem, right? FE410, yes. So this 250 is representing which one? This F5 yield strength, it will be represented, right? Like that. Got it now? This is your first type of the steel, structure standard quality steel, right? Note it and tell me everyone. We'll move on to the next one. Note this and tell me. So this is most commonly used for which one? These buildings, bridges, industrial, transmission lines, etc. For all these kinds of general elements, we'll be using this standard quality steel mostly. Is not? What tell me? See, once this lecture is over, its continuation will be there tomorrow in special class, right? It is there tomorrow in special class. Day after tomorrow also in special class only. Okay, got to be careful. What is it you are having? Done? So this is your first type of the structural steel, standard quality steel, right? What is the second type? You can say, if you just observe, fusion welding type. So there previously that welding was not properly suitable, na? Now this is mainly for this welding, right? Fusion welding type. Fusion welding type, you can say, right? What is the fusion welding? Mainly suitable for which one? For general construction, general structures, and particularly where it is suitable, you can say for general construction also it is suitable. And what is the particular usage of this? If you just observe, it is particularly suitable for what, everyone? It is particularly suitable for structures with dynamic loads, na? Particularly suitable for structures subjected to which one? Structures subjected to this dynamic loading. Okay, dynamic loading, right? So dynamic loading means which one? Earthquake loading and wind load, na? Is that no? So what is that carbon content, right? How much is that carbon content you are having? The carbon content will be 0.22, this is 0.25 only. Yes, yes. Welding is possible. In the first, welding is possible in standard quality steel up to 20 millimeter thickness only. I have written, welding, bolting and riveting you can do for any thickness, but welding is for which one? Lesser than or equal to 20 millimeter thick members only, that welding is possible, right? Other members welding is not that much possible. Okay, so it will not hold the members together. That is what. Okay. Right. No. Here carbon content is 0.2 to this 0.25. And what is the percentage elongation? Strain percentage is nothing but your percentage elongation. This is also which one? This 23% only. And what is the designation you are having if you just observe? What is the designation you can say? If you just observe, Fe410W, right? Fe410WA. So Fe410S means standard quality steel. W means what? Welding quality steel. WA, WB and this WC, right? What is the meaning of this WA, WB and this WC, all of you? What is the WA, WB and this WC? WA, WB and this WC, right? What is the WA, WB and this WC, everyone? Tell me. These are different qualities you are having, right? These are different qualities you are having, right? What are the different qualities? Quality A, quality B and quality C. These are corresponding to which one? These different temperatures of this welding, right? So welding type A, welding type B, welding type C. Depending upon that, you have to go for this WA, WB and this WA, WB and this which one? This WC we have to select, right? Like that. Is not? Shall we move to the next question? Sorry, next third type of this steel. What is the third type of this steel? You can say. Yeah, welding class, right? So it is welding can be suitable for all thickness, na? Bolting, welding and riveting. It is suitable only for few thickness or it is suitable for all thickness? It is suitable for this all thickness, you can say, right? Now next one, high tensile steel. HT, yes. So this is according to which code? IS 961, right? Indian standard 961, right? Fusion welding quality steel, it is according to which code? You can say Indian standard what? 2062, na? First one, standard quality steel is according to which one? IS 226, right? Standard quality steel is according to this IS 226. Fusion welding quality steel is according to which one? This IS 2062, right? 2062. And high tensile steel is according to which code? IS 961. Okay, like that. What is it you can say? The name itself is telling that it will be having that greater strength or smaller strength. It is having this greater strength, and which one? The main advantage is what? Atmospheric corrosive resistance. Atmospheric corrosive resistance we are having, right? Now tell me, what is the carbon content? 0.27 percentage. And what is the percentage elongation? As a carbon content is very much higher, so can you able to get the same percentage elongation as 23 percentage? No, we may not be able to get this 23 percentage, right? How much will be getting now? We'll be getting it as this 20 percentage elongation only, right? And now what is the designation if you just observe? Designation if you consider it, what is the designation you can say? Let us say that is your FA 570 HT. It is represented as this 570 HT means what is that HT you can say? High tensile steel, right? 570 will be representing which one? This ultimate tensile strength FU. Got it now? Note and tell me. So these are the different types of which one? These steels available, right? These are the different types of this steels available, you can say. Got it now? Note and tell me. Clear now everyone? Everyone clear? Hello? Done? So we'll write this and right. So what is it? You can say physical properties of structural steel. Tomorrow this first chapter will get over. Okay. SS. What is that SS? You can say structural steel. Na? Physical properties of the structural steel. Right. What are the physical properties of the structural steel you are having? If you just observe. First one, specific gravity. Specific gravity of the steel is equal to which one? 7.85. Okay. Specific gravity of the steel is 7.85. Right. So what is that? What is that rho S? What is that rho? You can say it is a mass density or it is the weight density, right? Mass density na. What is it? You can say same. 7.85 means 7850 kg per this meter cube only. No. If you know the specific gravity, you can get this mass density na. Right, mass density. Elastic modulus of this steel, how much we have to take it? 2 into that 10 power 5 MPa, right? MPa is nothing but your Newton per millimeter square now. Yes, absolutely, right? What is the Poisson's ratio? You can say. So this is taken as 0.25 and this is taken as your 0.3. As per which code 0.25? As per this IS 800 1984. Sorry, I have given 1987 na somewhere. It is not 1987, it is 1984 codes. Okay, where is the codal provision? 1984, not 87. Okay, that is 1984. You make it 1984. So as per this IS 800 1984, this was the value to be taken. As per this IS 800 2007 latest code, we have to take this 0.3 as the value. Yes, now modulus of rigidity. 0.8 into that 10 power 5, right? C equal to that, N equal to that G. These are the symbols we are giving for this modulus of rigidity na. 0.8 into 10 power 5 as per which one? This IS 800. Which code? 1984 code na. So 0.769 into the 10 power 5 MPa. Why it is changing? Because the Poisson's ratio is changing now. When Poisson's ratio is changing, that rigidity modulus also changes, right? What is that? How can you get that? E equal to that 2g into that 1 plus mu, no? G equal to which one? This E by 2 into 1 plus mu. Is not? When Poisson's ratio increases, denominator increases, that G value decreases, right? That is why compared to old code it is lesser. IS 800 2007. Got it now? Now what is another one? Coefficient of thermal expansion alpha equal to 12 into 10 power minus 6 per degree centigrade, right? So these are all the physical properties of which one? This is structural steel you are having, right? Got it now? Yes, you need. Old code is not discarded. I told you na, old code is not discarded. Old code, if at all it is a working water, wherever working stress method is compulsory na, we have to use that old code provisions only. What is that working stress method? Suppose if it is a water tank, whenever it is a water tank, which one is important? The serviceability is important or strength is important for that water tank? For water tank, serviceability is important or strength is important? Strength is important for, sorry, serviceability is important, na? That leakage should not be there. So whenever that serviceability is important, we have to go for which one? This working stress method only. Right, got it? Right, these are the physical properties of the structural steel, right? Noted everyone? See, I'll tell you, IS 800 2007, na, it is mainly insisting us to do which one? Use limit state method only, but it does not restrict the usage of which one? This working stress method. Wherever working stress method comes to be more appropriate, then you go for this working stress method, right? Okay, right. Want me to write all? See, this IS 800 2007 new code tells us to use which one? Limit state method of design. But what happens now? It also says that wherever, right? Wherever it is suitable, use the, wherever it is suitable, use which one? Use that working stress method also, it is said like that. Okay? That's one. Wherever limit state method will not serve the purpose and working stress method only serves, use working stress method old code. Okay? So that's why these are required. Got it now? Specific gravity, mass density, Poisson's ratio. What is this one? Yeah, yes, as in case of water tank. Coefficient of thermal expansion, right? Yes. So these are the names of each individual properties. Are clear? Yes, for full serviceability, which one is better? Working stress method only will be good, you can say. Is not? Is that link visible in the comment box? Link is removed. It is removed. Okay, here. Okay, like that. So is it clear? Shall I close the session? Like that we'll be having tomorrow this first chapter. Remaining things, what are there? Types of design, what is working state, what is limit state, and what is the ultimate load method. These three designs will be having, and different types of these sections, and partial safety factor, these values, and then questions we'll see. Tomorrow first chapter will get over. Okay, thank you. Anyone having any doubt, all of you? Anyone having any doubt anywhere? Anyone having any doubt anywhere? Right, thank you. I'll be closing the section. Thank you all of you. Thank you. Have a